Hello everyone, how are you doing? I'm gonna solve one problems which is a definite integral with a lower bound of 0 to 2 for a function x natural log of quantity x plus 1 dx. And you already know the technique for that one. The technique for that one is nothing except integration by part. You can make your ux. Nope, you cannot make your ux. Why? Because you have u dv, and then this is your du, this is your v. This one is the given one, and you have to use liate to define the u. Because if you make u, it's very hard to integrate natural log. Therefore, liate said logarithm to become a u. And your du is 1 over quantity x plus 1 dx. What is left is dv, which is x dx, and your v is x squared over 2. Therefore, the answer to this one using integration by part is x squared over 2 natural log of x plus 1 minus x squared over x plus 1 integral, and don't worry that I have a 1/2 here dx. Many students work very hard and they make this one a u, then they solve for x and they make this one a u squared, and it is possible to do that. But I love to use long division when I have an improper rational function. That's the best way. I think I'm not going to get confused. X squared over x is x. Therefore, you have x squared plus x. You subtract, you have a negative x. You don't have anything to bring down. Negative x over x is negative 1. Therefore, you have a negative x minus 1. And when you subtract, you have left 1 left. Therefore, you have x squared over 2 natural log of quantity x plus 1 minus 1/2. What is the integral of x? X squared over 2. What is the integral of a negative 1? Is a negative x. What is the remainder? 1 over x plus 1. And what is the integral of that one? Is the natural log of quantity x plus 1 from 0 to 2. Okay, that's not hard. You know 2 squared is 4. 4 over 2 is 2. 2 plus 1 is 3. Natural log of 3 is 1.09. Minus, I multiply the 1/2 through. That become 1/4 x squared, which is 4. My negative times negative is a positive. X is 2, negative times positive is a negative, and let me see if I took care of that too. Yes, when x is 2, 2 over 2 is 1. No, I didn't, because that's x over 2 and 2 over 2. And this one is negative 1/2 natural log of 2 plus 1, which is 3, and natural log of 3 is 1.09. Therefore, you have 2.18 minus a 1 plus a 1 and minus 1/2 times 1.09. These cancel out. That's 2.18. This one become 50. Half of a 9 is 4.5. 0.54545, and that's to become, when you subtract it, 5 from 10 is 5, 5 from 8 is 3, and 5 from 11 is 6, and 1 from 2. Therefore, this is only for the 2. Let's subtract the 0. 0 over 2 is 0. 0 times is a 0. That's make it a 0. That's make it a 0. Natural log of 1 is a 0. The 0 part is a 0. That's your answer. You know, I don't want to go forward without checking if my that's what's the beauty about the calculator. You can check right away and see if this is right. You go to right here and you're going to put x natural log of quantity x plus 1. That was your function from 0 to 2. Therefore, you can go to math, and number 9 is your integral from 0 to 2. And here you can either put y1 or you can put x natural log of quantity x plus 1. I like the y1 and respect to x. Remember, that answer might be different from mine because I got natural log of 3 approximately 1.9. Okay, don't criticize me a lot. And that become 1.647. You know, not bad, not bad, not bad. You know, my answer, you know, by the other calculator is really good. At least I have my brain left. Part of it. But somebody said, I don't know how to do integration by part. I want you to use trapezoid rules and see if the trapezoid, which is a numerical, your answer become like that one. Okay, let's do that. 0 to 2. I'm going to select n equal to 4 only to have 4 trapezoid. Okay. 0 to 2, middle of it is 1, middle of this is 1/2, middle of this one is 3/2. What was the trapezoid rules? Therefore, the definite integral from 0 to 2 of x natural log of quantity x plus 1 dx is approximately equal to b minus a, 2 minus 0, over 2. Where did the 2 come from? The area of a trapezoid, we do the average of the bases, times n, number of a trapezoid, which here we got 4. Then what was the formula? y1, this one uses twice for the left and the right, twice, y1, y2, y3, y4, and 1 y5. Remember, when I said y1 means f of x, same function when x is equal to 0. That's y1. When I said y2, it still is the same function, but your x is equal to 1/2. Remember that these are not different functions. Therefore, in here, I have x natural log of x plus 1, and I'm going to replace 0. Natural log of 0 plus 1 is natural log of 1. Natural log of 1 is 0. 0 times 0 is 0. I'm going to put 1/2. You have plus, but remember you need 2 of them. 2 times 1/2 times natural log of 3/2, because 1/2 plus 1 is 3/2. Next is 1. You put 2 of them, times x is 1, natural log of, we could put in 1. 1 plus 1 is 2. Plus, I need 2 of y4. y4 is the same function at x equal to 3/2. Therefore, your x is 3/2, and you have a natural log of 3/2 plus 1 is 5/2. y5 only uses once. y5 is your function when x is 2. 2 natural log of 3. That's my answer. 2 over 8 is 1/4. 2 times 1/2 is 1. Natural log of 3/2 is the same as a natural log of 3 minus natural log of 2. Natural log of 3 is 1.09. Natural log of 2 is 0.69. Plus 2 times 1 is 2. Natural log of 2 is 0.69. 2 times 3/2 is 3. Natural log of 5 minus natural log of 2. But in here, you don't have to do this. You can type them in the calculator, natural log of 5, and it'll give you the answer. Plus 2 natural log of 3 is 1.09. I just want to let you know that some of these natural log quantity, you should know it, but I'm going to use a graphing calculator right here, and I'm going to show you how easily you can do that. See, you have x natural log of x plus 1. You go to your variables, y variables function, and the first one, your input was 0. And see, you get that 0. But I'm not going to press enter. I go to variables, I'm going to press function y1, and I press 0, and I'm going to use only one of it. I need 2 plus 2 times variable y1, but this one, my x is 1/2. Plus 2, I need 2 of these, and this time my function uses x as a 1, plus 2 y variable function, but my x value here is 3/2, plus you use 1 of y5, which is your function at x equal to 2. Press enter, 6.73. But remember, you gotta divide it by 4. 6.3 divided by a 4. God, 1.68. What was the exact? Pretty close, pretty close. You know, if somebody said round it to 10th, this is 1.6, this is 1.7. I hope you don't cry over 0.1. Therefore, in here, the answer become 1/4 times 6.737, and that approximately become 1.6844. Okay. But somebody said, why don't you use trapezoid rules? I think trapezoid rules are a little bit better because you use a parabola. Okay, we said, man, what a line. We said trapezoid rules from 0 to 2. You have this one, and the midpoint of these. Remember, this is 2 parabola. You use this one once. You use this one 4 times. You use this one twice, because when it's in the middle of a parabola, the formula said 4 times. This is 4y, 1, 2, 3, 4, and 1y5. And the formula was b minus a over 3n. And it was 1y1 plus 4y2 plus 2y3 plus 4y4 plus a y5. Okay? Is 2 minus a 1, 2 minus a 0, I'm sorry, over 3 times 4. This one is f of 0 plus 4 f of, if this is 0, this is 2, this is 1, this is 1/2, this is 3/2. 4 f of 1/2. Next, 2 f of 1. 4 f of 3/2 and 1 f of 2. Okay, let's go right here. And I'm going to go back. I think we had all of that. I think all of them was right here. But remember, y1 of 0, but in here I need 4 of them. Everything is the same. This is 2, but the middle of this one not needed right here. I'm changing some of the 2 to a 4, and I think the last one is 1y5. Pretty good. Done. All of these inside here is 9.89, but you gotta divide it by 2 over 12, which is by 6. Let's divide it by 6. Hold your finger crossed. What was my exact? I want you to compare it, please. Look at the error you make on the Simpson's rules. Only with two problems. 1.68, 1.648, 1.64. And Simpson's rules is a program inside the calculator, but I bet you n is probably about 10 or 11 or 12 or something like that. It's not going to be 4, because if I make my n 6 or 7, it becomes the same. Therefore, that was another example regarding the Simpson's rules and trapezoid rules, and you see how important the Simpson's rules is, because it pretty much with 2 or 3 problems are going to give you the exact answers. Thank you. And this is Larson 8- I don't know what it is 8-6, and the next section is going to be improper integral. Thank you. Bye.